Right, as Mr. Payne would say, good morning, good afternoon, or good evening, depending on when you're watching this. And we're going to start lesson 8.4, and we're going to start getting ready to deal with completing the square. And we're going to talk about the vertex form first to get it that way, and we're going to be working with that a lot. I want you to take a look at it. So we've got that one right there. You guys know from previous lessons that if I want the turning point, it's the H comma K, which means the H comes from inside the parentheses. And we always do the opposite of that. So the opposite of a -3 is a +3. And then our K we take from the outside. That's the amount that we're going to shift up and down. The inside is how much left to right. And we do not change the sign on the piece outside, only the one on the inside. So we got a +2. So there's your turning point. Now in part B of this first exercise, they want you to determine the range. So we're going to bring that back into play here. I would obviously go and plot 3, 2. So 1, 2, 3 to the right and up 2. Put a point for my vertex. There was no negative, so it was no flip, so it's a right side up parabola going like that. So you should have a sketch that looks like that. And we want to talk about the range. Well, we know domain is left to right, and that would be all reals because this thing goes on forever if you take a look at it to the left and keeps going forever to the left and goes forever to the right. Range, on the other hand, a little bit different here. Where's the low point on the range? Well, the low point is right here. How low was it? Well, it started at a height of 2. So for our range, write down that you start at 2. And where does it go? Well, once again, you take a look at it, it's going on forever upwards. So that means it's going toward, you got it, infinity. Infinities always get parentheses, and the 2 is a valid solid point. So you should remember it gets a bracket, and that's your range. Goes from 2 to infinity, inclusive of 2. Let's move on. Alright, so in question 2 now, they want us to practice a little bit of multiplying again. Some of you guys are going to do tabular, so I can go back to the old thing with the tabular. And keep in mind that x plus 5 squared really means x plus 5 times a second x plus 5. So that's where tabular is going to come in. So if I do an x plus 5 and an x plus 5, okay, I can multiply and I get my x squared out of this. 5 times x in the upper right hand corner is 5x. Lower corner is 5x also. And then 5 times 5 is 25. When I pull this stuff out, I get an x squared there. I do the diagonal, which are like terms. You pull them out, you get a 10x. And I pull out the 25 here. So we get x squared plus 10x plus 25. Now these are special factors when they're the same squared that way. If you do the same with x minus 1 squared, I'm going to tell you it comes out the same thing. I'll give you the answer on that one. It actually comes out x squared, and then a minus 2x, and then a plus 1. Now a shortcut to all this. If you don't want to do tabular when you get one of these, all you have to do is square the first term, which I did, get an x squared. You can square the last term for the last piece. -1 times -1 is +1. And then you need 2 of these to multiply together. Well, what's -1 times x? A -1x. So I need 2 of those -1x's, which makes -2x in the middle. Go back to the top one if you want to make a look again. What was x? Happens when I square it? X squared. What happens when I square the 5? I get 25. What happens when I get 5 times x? I get 5x. And when I double it, I get 10x. Oops, I forgot my x here, by the way. So now we fix that. All right. I want you to do C now. Pause the video and do C. And you try the shortcut if you want, or go right to tabular, whichever way you want to deal with it. Alright, so here's a key piece here. They want to know from exercise 2, what do you notice about this form here? What's true about the relationship between the B and the C? And I don't know if you guys can catch this or not, but there's a relationship between 10 and 25. There's a relationship between -2 and +1, and there's also in part C. And I'm going to just reveal it to you just so you have it. But basically, if I take half the B, if I take B and divide it by 2, remember the 10 is my B, because my A is out in front here. There's my B, and this is my C, okay? If I take half the B, okay, so in this case, I take half of B, what's half of 10. So in this case, it's 10 divided by 2, which is 5, right? And what happens to go from 5 to 25? If I square that, okay, I'm just taking half that. It's not actually an equal sign here. If I square that, I get to 25. So what you're doing is you're taking half of B take half of b, and then square it. You'll get your c. So if I take half of a negative 2, so take negative 2, cut it in half, what do I get? I get negative 1. What happens when I square negative 1? I get positive 1. And that's exactly what turned out to be my c. So that's a piece that we want you to be able to recognize, okay? In part 4, we're just practicing the perfect trinomials again, perfect square, write it in factored form. So yes, I can turn around and do this here. In this, we've got a trinomial here. I have no GCF, nothing like that. So if I go to the AC method with the X box, I need my AC here. So you guys know that's 1 times 100, so that's 100. And my B is the 20 down here, right? So what factors of 100? You can use your calculator once again, or if you're getting pretty good here on this. The nice thing is, it's going to turn out to be 10 and 10. Okay? And then if I go and do the whole thing, and I go through the whole kit and caboodle here, and you're actually factoring it, you actually get x squared. You bring that down, you bring your 100 down at the end, remember? And then the 2 in the middle, so plus 10x, plus 10x. Now I got to GCF the first two, you got to factor it by grouping. So what do they share? An x. I am left with x plus 10. And the second one, what do they share? A 10. And I'm left with x plus 10. So I have an x plus 10 in parentheses they share. And guess what? The outside parts put together is also an x plus 10. And if it's a perfect square, okay, a perfect square like this, that's going to happen every time like that. So you may want to come up with something here that really ties into this. And you can do the other two. I'll let you do B and C yourself. But then there's a little discovery piece there going. Maybe you'll figure out the shortcut. How can I go to this right away without going and using the AC method? But I want you to pause the video and practice 2 more factoring, because we know we still need work on that. And now we're going to then move on to completing the square.
I mean, how am I supposed to know what